Hi, welcome to mathematics. In this video, we want to solve for x in x times x equals x raised to power square root of x. Let's say solution. We have solution. We have x times x equals x raised to power square root of x. So from here, let's recall that if you have m raised to power p times m raised to power q, this is equals m raised to power p plus q. So from here, this x times x will give us x squared, right, equals x raised to power square root of x, right? So we have this. So now let's say our a to be equals to square root of x. And if a equals x, that means that a square will be equals to x. And if you have a raised to power 4, this will become x squared. A raised to power 4 equals x squared. So now from equation star, which says that, which says x squared equals x square root of x. Now we have x squared. What's our x squared? We have a raised to power 4. So a raised to power 4 equals, what's our x? Our x is a square. So we have a square square root of x. So what's our square root of x? And that is a, right? So if you simplify that, we have a raised to power 4 equals a raised to power. This is product power law. When number which is equal to a certain power is again raised to another power, the powers are multiplied. So we have a times 2, we have 2a. So from here, we introduce log to both sides. Introduce log to both sides. So, and if you do, we are going to have log a raised to power 4 equals log a raised to power 2a. But recall that if you have log m raised to power p, this is equals to p log m. So applying this to this, we will have 4 log a equals this 2 here will come forward as well. So 2a log a, right? So we can transfer this to the other side. So we have 4 log a minus 2a log a equals 0. So since log a is common, so we can factorize it out. So we have log a. So what will be left here? We have 4, and what will be left here? We have minus 2a equals 0. From here, you observe that log a equals 0 or 4 minus 2a equals 0. So you can just say log a equals 0 or 4 minus 2a equals 0. So let's just take the first case. You can just say case 1. So if we choose case 1, so we have log a, that is in base what? In base 10 equals to 0. So we have log a in base 10. This is equals to log 10 log 0 in base 10, right? So, and you observe that this log 10 we cancel this log 10. Sorry, this is 1. Sorry. So it's when we have 10 raised to power 0. So this will become 0 as this one. So now we have a equals 1, right? So but we are not looking for here, we are looking for x. So we say, recall that our x is equal to what? Our x is equal to a square. So and we have gotten our a to be equals 1. So we can easily substitute a here. So we have x equals, what's our a? 1. So our 1 square will give us 1. So our x is equal to 1. So you can just say this is x1. So for the second case, that is case 2, we have 4 minus 2a equals 0, and we have 4 equals 2a, right? So here we can easily divide both sides by 2, this by 2, we know this, we cancel this, and we have 4 divided by 2 give us 2 equals a. So we can make you declare that a equals 2. So again, so we are not looking for here, we are looking for s. So we say, we call that x equals a square. And if x equals a square, so we have x to be, what's our a? So we have 2, and that is 2 square. So we have x equals 2 raised to power 2 will give us 4. And you can declare that this our x2 equals 4. Therefore, our x1 is, what do we have? We have our x1 to be 1, right? Our x1 equals 1, and our x2 is equals to 4. So this answer. So, and you can easily check for both this value. Let's say check, we have x times x equals x raised to power square root of x. Let's check for x1, so which is equals to 1. So we have 1 times 1, right? So equals 1, then square root of 1. So 1 times 1 will give us 1, equals 1. Square root of 1 will give us 1. So we have, want to check if this is equal, we have 1 is equals to 1 is to power 1 will give us 1. So that means that this is valid, right? Also, for the second, let's say x2 equals 4. So let's see. So we have 4 times 4 equals 4 raised to power square root of 4.